I, Dharmik Chauhan, Hello. Dharmik Chauhan, Department of Mathematics, Pandit Dindayal University, India. Under the mini symposium, I present my typological optimizations of ultrasonically star-casted quasi-isotropic composite reinforced with carbide and sulfide using the box Beacon design. In the motivation to make the quasi-isotropic composite for the automotive industry, and we check the physical properties like the density and porosity, and also evaluating the characterization of quasi-isotropic composite using X-ray diffraction, morphology, and microstructure for our aim to optimize the tribological parameter like normal load, sliding speed, and temperature to check the tribological wear analysis with using the response surface methodology. And under the response surface methodology, we choose the box bracket method. After the literature, we review the wear surface morphology at different temperatures after 10 cycles and scanning electron microscopy for morphology for one surface out surface. And also we check the X-ray diffraction patterns for the different samples. This is our aim to the cast material, quasi-isotropic material for this machine, stir casting machine used for producing the quasi-isotropic composite through squeeze casting. And in this casting, we choose the aluminum 6061 with reinforced with boron carbide and sulfide as a molybdenum disulfide for the stir casting. In casting process, 4% buffer C and 1% molybdenum disulfide, we choose an 1200 gram aluminum are used. For the methodology, we use after the producing the casting, we using the examine for our experiment, we cut the specimen using EDM wire cut machine. This is the cutting process. And after we choose the pin on disc tribometer for the wear loss and structure analysis, pin on disc tribology setup. And this is the pin on disc, and this is the normal load, sliding speed, and specimen. And this is the counter plate EN31 steel disc counter plate. This is the specimens for our experiment in pin on disc tribometer. This is the methodology to this is the optical microscope in our campus. Specimen for density and porosity, Keller's reagent. For the etching, we prepare the Keller's reagent 190 ml distilled water, 5 ml nitric acid, and 3 ml hydrochloric acid, and 2 ml hydrochloric acid. It's used to making the Keller's reagent. For the reagent, we check the microstructures and this is the stir casting parameter. We choose this parameter for our casting process and our quasi-isotropic composite. And this is the pin on disc parameters and factors. In this research, we choose 3 factors: normal load, sliding speed, and temperature. For normal load, we choose upper level and lower level, and also sliding speed and temperature. We choose 10, 40, 0.5, 2, and 50 and 200 degrees Celsius. And we using the Minitab software choose our middle points 25, 1.25, and 1 to 5. This is the chemical elements of aluminum 6061. This is the standard elements, and this is the in-code analysis of our aluminum 6061 chemical compositions. This is the mechanical properties of aluminum alloy 6061. This is the gauge length diameter and this all things. This is the flow chart of box-Beacon experimental design. To first we define the problem. After defining problem, we have some objective and the independent variables and responses. Then we suitable design. In this design, we choose the response surface methodology, and in the response surface methodology, we have 2 methods: center composite method and box-Beacon design. We choose the box pattern design. After the box pattern design, conduct the experiment and collect the data. After collecting data, we analyze all things ANOVA, SN ratio, and determine optical model. In last confirmation test and condition and the error prediction. This is a box pattern design, and we choose a design summary for box pattern. We have three factors: one replicate, base run 15, and total run 15, and center point 3. This is the our coded factor level for box pattern design. This is the alpha denoted as the normal load, beta denoted the sliding speed, and the gamma denoted temperature. This is the -1, 0, and 1 coded factors. This is orthogonal array for the box pattern design, normal load, sliding speed, and temperature. For the alpha, beta, gamma, we choose the box pattern design, and in this box pattern design, we have three factors, three levels. So we multiple combinations and 15 combinations we have derived. And after the 15 combinations, we choose this box pattern design, and we started our experiment. This is the result and conclusion. Discussion. This is the microstructure of quasi-isotropic composite with different multiplications, magnifications. The increase in the density values was due to the addition of B4C and MOS2. We evaluate the theoretical density using the rule of mixture. This is the rule of mixture. This is volume fraction of metal into density of metal with addition of volume fraction of reinforcement and volume fraction of our density of reinforcement. And also we calculate the rule of mixture, then we calculate 2.70 gram per centimeter cube and received the experiment density, the Archimedes principle, using the Archimedes principle as 2.69 gram per centimeter cube, which are the agreement with each other. The calculated porosity percentage at 0.40 percentage after getting the value of the theoretical and experimental densities. This is our morphology of quasi-isotropic composite with different samples and with different magnifications. So this is the oxidation, this is the first particle, adhesive wear, then all things are shows. We check the microscopic hardness values of aluminum 6061 for different location. This is the mean of all five values at 99.04, and this is our last value of quasi-isotropic material because this is aluminum 61 plus using the reinforcement of B4C and MOS2, we derive 109.68. It is more than the pure aluminum 6061. Okay. This is our quasi-isotropic composite, X-ray diffraction with aluminum 6061 alloy. This all the pink stick is denoted the aluminum 6061. This is the B4C and this is MOS2. For this test, we choose the ASTM E329422 guidelines were followed for the preparation of the specimens. The presence of aluminum 6061 confirmed by this 2 theta degree and boron carbide fixed at 2 theta degree, this and molybdenum disulfide. This is the coefficient of friction versus sliding time of normal load, this 25, 40 and 10, and sliding speed 0.5, 1.25, 2.0 meter per second. This is our coded coefficient, and this is the alpha normal load value of P value is 0.09. It is slightly smaller than the 0.05 level. That just means the P value is significantly at 0.05. A normal load is significant value. This is regression equation where V loss is regression equation and alpha and beta gamma is there. This is the quadratic equation. To validate the regression model, this model, we use the confirmation test for the conducting the normal load as a 25, sliding speed as 1.25 meter per second, and temperature of 125 degrees Celsius. The Wear loss from the experimental was 6.05 milligram and predicting the 6.135 milligram. The small variation of the two results indicate a strong agreement and confirmation is our model is accurate. Then is it ANOVA, analysis of variance ANOVA. This is the this value 2.58, F value of 2.5 is a model value. It means its model value is more than the p value 0.15. It means the F value model is the significantly approved. And after the linear model, we have 0.03 core. It means it is significant at level 0.05. So our linear model is significant, and after normal load also significant for zero point 0.05 level. This is our conclusion. We actually made the quasi-isotropic composite for ultrasonically stage casting, and we effectively cast using the stir casting machine, and we optimize and the research and the theoretical density calculate 2.70 gram per centimeter cube, and experimental density is 2.69 gram per centimeter cube. And the XRD patterns indicate the presence of the aluminum 601 before C and MOH2 in this material. Also, we check the Vickers hardness of 99.04 HV 0.5. It's means 500 gram per 10 dual second, 20 second dual time. And also we check the 109.68 HV 0.5. It's higher than the aluminum. It means our material is perfectly made, and in ANOVA, the F value is 2.58, indicate the overall significance of the model. And also then the 0.05 level, P value, normal load is very significant. In tribological, normal load is more effective sliding speed and temperature. This is our references. Thank you.